All right, here's an example we're going to work. So it's the integral of x cubed minus 2x squared minus 4 over x cubed minus 2x squared dx. And something I haven't mentioned yet is you should notice what the degree of the numerator is and what the degree of the denominator is. On all the previous problems I worked, the degree of the numerator was smaller than the degree of the denominator. And we just kind of went right to work on it. This one, the degrees are the same. If the degrees are the same, or if the degree of the numerator is bigger than the degree of the denominator, then your first step is long division. I've got to take this and do long division. It's probably been a while since you've seen long division of polynomials. So x cubed minus 2x squared divided into x cubed minus 2x squared. And remember this, I'll put 0x for 0x to the first to hold that place, minus 4. Well, I'll go x cubed goes into x cubed. How many times? 1. Put a 1. Then multiply. 1 times x cubed is x cubed. 1 times negative 2x squared is negative 2x squared. And we'll subtract. I like to put the minus sign on the outside, put that little polynomial here in parentheses, because you have to remember this negative sign is going to distribute. So x cubed minus x cubed is 0. Negative 2x squared minus negative 2x squared is what? 0. So I'm going to go ahead and write that. 0x squared. Bring down the 0x. Here's minus 4. So really all I have left here is minus 4. How do I know that this is the remainder? The degree of negative 4 is less than the degree of my divisor. And there's my remainder. And you might remember this. I can write this as plus remainder, which is negative 4, over the divisor, x cubed minus 2x squared. So I've done the division, and now this integral problem, which was the integral of x cubed minus 2x squared minus 4 over x cubed minus 2x squared dx, now it equals the integral of 1 plus negative 4 over x cubed minus 2x squared dx. So I've done the long division to rewrite the fraction as the quotient plus the remainder over the divisor. This is two separate integrals. This will be the integral of 1 dx, that's easy. Now I wrote minus the 4 in the top, but you can write minus the integral of 4 over x cubed minus 2x squared dx. Now, this is easy. This is the partial fraction decomposition. So, what's that first integral? Let's get that out the way. That's x minus the integral. I got to factor the denominator. I got to factor out an x squared. X squared times x minus 2. And then I have to do partial fraction decomposition for this. So I'm going to go to a new page for it. To set that part of this problem up. I might just say, okay, I got to deal with that. Let's do the algebra part. So I have 4 over x squared times x minus 2. That will equal, now look, that x squared, that's that part I did a few minutes ago. A over x plus b over x squared. And then x minus 2 is linear, so plus c over x minus 2. And I need to solve this for a, b, and c. Well, I'm gonna multiply everything by the least common denominator, which is LCD is x squared times x minus 2. So if I multiply that, look, this is going to wipe out the denominator on the left side. I'll just get 4. A times what's left over when I multiply a over x by x squared times x minus 2? I get a x times x minus 2. What about b over x squared? B times x minus 2. And what about c over x minus 2? C x squared. Now think about what you can pick for x to help you out here. Like, how about x equals 2? So I'm going to say let x equal 2. Well, the left side is just 4. So I'll get 4 equals a times 2 times 2 minus 2 plus b times 2 minus 2 plus c times 2 squared. 4 equals, well, the a wipes out because that's going to be a times 0. And the b is gone. What about c? 4c. C equals 1. Now, what's another good number to pick for x? 0. And look at what you have here that'll kind of get rid of some of these terms for you. Let x equal 0. So that would be 4 equals a times 0. And I'll write 0 minus 2, but you really don't even need to write that step. Plus b times 0 minus 2 plus c times 0 squared. So 4 equals negative 2b, and b will be negative 2. Now at this point, see, I still need to find a. At this point, I could maybe go ahead and plug in what I know is C and what I know is B, and maybe you want to pick a different number for X and see what happens. But let me go ahead and plug in what these numbers are that we found. So we'll have this. 4 equals, don't have A yet, AX times X minus 2. B was negative 2. So plus or minus, you can do minus 2 times X minus 2. And then C was 1 plus 1 times X squared is just X squared. I'm going to distribute this negative 2, combine like terms. I'll distribute the AX. 4 equals AX squared minus 2AX minus 2X plus 4, because you got that negative that you're distributing, plus X squared. I'm going to subtract 4 from both sides. Let me combine like terms first. AX squared, no, I'm going to do this instead. I'm going to move these terms over to the left side. When I subtract 4 from both sides, I get rid of the 4's. This x squared will be negative x squared. And then I have plus 2x. And that's going to equal ax squared minus 2ax. And I'm going to look at that and say a is negative 1. Who knows how I'm getting that? Yeah. All right, look right here. Ax squared, they got to be equal. Negative x squared. So a equals negative 1. And you could maybe double check that by even checking these coefficients. So let's go back to the problem. Right here was the problem. And I will go to a new page on this. So we had the original problem at this point. I'll say go back to the calculus problem. I have x minus the integral. It was a over x. A is negative 1. Negative 1 over x plus b over x squared. And b was negative 2. Negative 2 over x squared. And c over x minus 2. And c was plus 1. It was positive 1. 1 over x minus 2 dx. And then you do the integral of each of those.